I am Nicholas Bornos of Capitaling, and I'm delighted to welcome you to this panel discussion session on the topic of U.S. shipping's energy transition, alternative fuels, and decarbonization. This is a topic, it's a global topic, and obviously a topic that is particularly relevant also for U.S. shipping. And I would like to thank DNV, who has been our partner all around the world, for putting together this excellent panel. I will turn over to Simon Mockler. Simon is the Regional Director for Decarbonization, DNV Maritime Americas, and I will let Simon introduce our panelists, John, David, Paul, and Jake. A big thank you from me, and Simon, the floor is yours, and thank you very much.
Thank you very much, Nicholas. And good morning, everyone, and good afternoon and good evening to anyone joining us from elsewhere around the world. We have a fantastic panel for you all today. We've put together some very distinguished representatives of the US maritime community to talk through and discuss the scale of the challenge that we face with the energy transition in US shipping. We have David Cummins, who is president of the Blue Sky Maritime Coalition. Blue Sky is a non-profit strategic alliance which has been formed to accelerate the transition of waterborne transport in North America towards a net zero greenhouse gas emission goal. And prior to his current role, David worked as an executive with Shell for more than 35 years, including as a commercial and business development manager for shipping in the Americas, and Vice President of Shell Korea, managing relationships with shipyards. Joining us from Wartsila, North America, is John Hatley, General Manager for Market Innovation. John specializes in finance and environmental monetization for decarbonization, which includes investment analysis of maritime projects. He acts as advisor to Poseidon Principal Signatory Banks and Sea Cargo Charter signatories. John is bringing over 40 years of marine experience across a whole range of business development, ship operations, and design responsibilities. Joining us from the Pacific Northwest is Paul Manzi. Paul is VP Asset Management with Crowley Shipping. He has more than 37 years of experience in the maritime industry, both at sea and ashore, and in his current role is responsible for asset management of Crowley's ship assistant escort business, as well as Crowley Alaska Tankers. And then we are joined also by Dr. Jake Russell. Dr. Russell is a fellow at the Advanced Research Projects Agency Energy, or ARPA-E. This is the Department of Energy's high-risk, high-reward funding arm. He has particular interests around maritime decarbonization, ocean power systems, and materials for improved electrical transport. And Jake holds a PhD in materials chemistry from Columbia University. I'd like to maybe start our session here just by trying to set the scene somewhat before I turn over to our panelists for their specific input. As Nicholas indicated in the introduction, decarbonization and the energy transition is a global challenge for shipping. The world as a whole is going through a massive shift in our energy model, and this is unmatched in both scale and rapidity to anything that we have been through in the past. For shipping in particular, the political, regulatory, and commercial pressure to decarbonize is mounting, and this is being driven by the sort of broader sense of urgency in society at large as we begin to recognize the costs of climate change, and that we are far off track from the targets that the international community has agreed from the Paris Agreement. Today, maritime transport is responsible for about 90% of world trade and nearly 3% of world energy consumption and resulting emissions. As a hard to abate sector, shipping is going to see our share of emissions increase as other sectors pursue aggressive decarbonization strategies through energy efficiency and electrification pathways, which are not available to us in the same scale. The International Maritime Organization has set an initial strategy to halve shipping's total emissions by 2050 through the introduction and the ratcheting up of carbon intensity measures. However, this is not aligned with the expectations of many of our stakeholders. including, most relevantly to our discussion today, the signatories of the Declaration on Zero Emission Shipping by 2050, which include signatories of which include the US government from COP26. Even this ambitious goal for a net zero 2050 future may not actually be aligned with a 1.5 degree warming scenario, which would entail even more aggressive cuts in emissions at an earlier time frame. So for shipping to be able to meet this challenge and transform the energy model that we work in, we are going to need to employ every tool in the toolbox. We are going to need to collaborate on a scale that we have not seen before, and we are going to need to innovate faster than we have before as an industry. This is going to be everything from optimization of the way that we utilize our shipping capacity to reduce our total energy demand, looking at the next generation of energy savings and efficiency measures on board to reduce our consumption, and ultimately is going to need a transition to low and zero carbon alternative fuels, the vast majority of which are simply not commercially viable or available in sufficient quantities today. So with that in mind, and hopefully having not put too much sense of doom and gloom into either my panel or the audience, I would now turn to, I think first Paul Manzi, to give us some of the ship owners' perspective on this challenge. I mean, Paul, from your perspective, what are the uncertainties that ship owners most need resolved as you start to look at investment decisions for your current and future fleets to meet this challenge? You're on mute, Paul.
The most common language in the current COVID situation. So good morning, everyone, and thanks for having me on the panel. And that is a great question, because at this time, as a ship owner and trying to renew a fleet or manage a fleet, we are managing in a tremendous amount of ambiguity. And as we look across the landscape, you know, there's three real areas that need attention, and we're focused into. One is regulatory clarity, and I'll talk a little bit more about that. You know, we struggle with commercial incentives and alignment with regulation and customer needs, and finally fuels. And you touched on the fuel situation, and from our perspective, you know, I look after both large assets, you know, Aframax tankers, and small vessel ship assist and escort. And I'll kind of give my perspective comes from both of those. When you look at regulatory clarity, you know, we're dealing with a very different regulatory regime across the U.S., going from California to the Gulf Coast to the U.S. East Coast and Florida. I'm talking from a U.S. perspective solely. The California is pushing hard, leading the way in decarbonization across the U.S., and that's where our ship assist and escort business is currently located. We operate there a substantial amount of business there, and as we look across that horizon, we are being pushed to make changes in technology that may not be the best technology for what is a 30 or 40 year asset in the future. So, you know, getting that regulation squared up, and it's around three places, right? It's around the fuel, and not just the fuel itself, which is difficult. You know, we're approaching fuels and fuel vectors that the Coast Guard hasn't regulated yet, that the class societies are just beginning to grapple with. Where do we stow it? How do we process it? You know, what is the net technical issues associated with that? And again, we're planning, you know, typical U.S. assets have 30 and 40 year lifespans. So the regulation will change over time. And how do we account for that? We're seeing that on the West Coast now with cold ironing tankers. You know, refitting those just to be able to cold iron at the dock is $2.5 million a copy. So, and that's driving us. As we build the first all-electric tug, we're actually having to craft the regulation as we go with the Coast Guard and our ABS, our class society. When we talk about commercial incentives being aligned with regulation, well, the challenge with that is, the customers want decarbonization, but they're not quite ready or know how to pay for it yet. So while we are acting in alignment with our value to bravely advance what's possible to elevate people on the planet, we're kind of walking out in the lead on this. So that becomes a challenge. So, carbon credits, we are trying to figure out how to value an asset that is a zero emission asset right now. We struggle with that. So it's not clear around how do we value the carbon credit side of that. When we look at commercial and regulatory and what is available for us to even look at financing new vessels, we're having to reach into places for grants and look to the government to subsidize some of the new construction where we can't. And on the West Coast, we see this burden being shared both by the terminal operator and the owner, and the charter is kind of left out. So the person who's paying the bill is not in the mix yet. So we're trying to, as we work, looking for commercial terms that bring that all into alignment. So that's the commercial incentives and regulatory alignment. Right now, it's very fragmented, and we're dealing with a hydra essentially trying to bring it into terms. And when we talk about fuel, we have a bold goal to cut our scope 1 emissions by 42% by 2030. So we are deeply invested in fuels, in understanding fuels and what's available to us. And right now, it's limited. So as we look at it, we see, biodiesel and renewable diesel are the two prime vectors for us in the very near term. Both of those are limited. Most of the feedstock for those is directed to the aviation industry. So that makes it a challenge to get a reliable bead on the feedstock. And the biodiesel is a 20% blend up to 100% blend. There have been some tests at 100%, and that seems to be working well. But in the volumes, should that become a primary vector for fuel in the Jones Act trades with the large vessels, there's not enough. There's simply not enough. And if we look at tankers and ships that are burning very low sulfur heavy fuel oil, there's nothing to replace that yet in current fashion or to meet our goals by 2030. And I think the pieces we talk about those future fuels of hydrogen, methanol, and ammonia, building those out into a future state from where we are is sort of invisible. We don't know how that structures are going to occur, how the infrastructure is going to appear. And while there is money available for ports to do that and terminals to do that and progress those infrastructures, we're not going to see that for 10 or 15 years, but before it gets built out. At least our opinion is before it gets built out where we can use it. So I'll pause there for thoughts and anybody else who wants to pile into my perspectives.
Thank you, Paul. And I think I'd maybe turn next to John as someone that has that broader view across, that's been working in this area, looking at the broader view across the whole maritime value chain. I mean, where do you see the biggest barriers? I think Paul gave us a good overview of the ship owner perspective and where they see roadblocks to us, but where are you seeing them from your perspective, John?
Thank you very much for having us today. It's much appreciated. But kind of parallel to what Paul said, I think if we look at a few things, what is this future fuel mix going to be? Well, it's not going to be any one particular fuel. And I look at it to try to understand it in 4 A's, very simply put: abundance, availability, affordability, assignment. Assignment, number 4, is probably the toughest. And what I mean by assignment is it from well to tank to wake, black, blue, or green. we all know about abundance, availability, affordability, but it's the assignment that's crucial. And too often, you know, representing an engine manufacturer, capital goods, it's engineers, products, and want to talk about it, not why. So we'll just briefly touch on it because this is a financial perspective. Let's talk about the engineer's it. Fuel flexibility is how engineers describe things in nano details of features and benefits, and they get all tied into this. How it can work, how it's really great, how you need more it. For the financial audience, the reciprocating engine technology will be ready to combust the future fuels before they are here in the 4As. Milestone signals. 2003, verified biosynthetic methane. 2015, methanol with Germanica. It's been now running for 7+ years. 2022, ammonia. 2025, hydrogen. So let me put aside it because we want to understand the why and the drivers, strategic financial relationships that frame up these opportunities. Really, what flexibility across the board really means is it's a real asset option. And those real asset options, as Paul touched on, where certainty breeds the investment, the amount of capital that flows will come with clarity. You've got a long-lived asset, 30 years plus in Jones Act, and a rapid machine gun fire of changes across the regulatory environment. So to me, the new business window of opportunity and the minimum time and minimum cost, you need a real asset option whose values are the greatest in the times of greater uncertainty. So you have to look at how can you future-proof and just de-risk your longer-term investment against this rapidly changing topography of regulation, policy, political will, amongst the mix of all these different things in the decarbonization era. What fuels will be in transition? There's no single answer. Probably talk too much. So the others get on and we'll come with some questions later.
Thank you. Thank you so much, John. And I think I'd next turn to David. We've heard two, I think, very interesting things in particular there from Paul and John. One thing Paul said that leapt out to me is a fragmented value chain. And we now have a fragmented value chain trying to solve the problem of John's 4As, while also managing our risk exposure through the industry. What can we do to overcome this, David? How do we solve this? Oh, you're on mute, David.
Let me start by coming off mute, and then let me start by thanking Capital Link and DNV for putting this together. You know, the Blue Sky Maritime Coalition was born asking ourselves over and over again, does the world really need another coalition? You know, there are so many people in this global problem working in this particular space, but there's a couple of things that were unique about how we set up. And one was that the solution space was going to be very unique in the US and Canada than it was elsewhere in the world. That 30% of those shipping emissions come from the regional and inland space, that there wasn't a lot of action going on around that. But the other thing that as we formed, we wanted to look at this value chain from end to end and go way earlier than the well and way later than the wake, and look at every player that's involved directly, indirectly, or a supporting cast to moving product from A to B, where part of that movement happens over water. So we were looking at this as one problem to solve and not a series of transactional steps that ship owners have to solve and governments have to solve and engine manufacturers have to solve and port authorities have to solve and consumers that cause products to be moved on water have to solve. And we're finding that you need collaboration, and we've organized the solution space and the roadmap and milestone thinking into 4 separate categories, but then we make sure those aren't siloed. We bring those together in a collaborative way. And those categories are technology, infrastructure, and fuels, which are very linked. And John has talked about that, Paul has as well a little bit. Then we have policy, regulation, and incentivizing first movers. You have to make it a level playing field. Then You also have commercial financing, chartering. The way that relationship works will need to change as well. And then forget about anything that we're waiting on. There's technology today to go after measuring. You control what you measure, and optimization of daily operations on an industry scale, not on a company or a port scale. So using things like, machine learning, AI, optimization routines that turn shipping into a future that looks way more like an Uber model than a taxi model. I would like to build, I think you started in exactly the right place, which is the ship owners, because that's where the capital risk is. That's where all this collaboration has to come together. And Paul talked a lot about, what is a zero emission vessel? How are you going to get a return on that? How do you make that a level playing field, not only in the capital cost, but the operating cost? But the other question ship owners have to answer, because in the US, uniquely, we have inland vessels that run for 70, 80 years. So if you're going to retrofits, and dealing with that issue is somewhat unique to what we're doing here. And so a simple question is, what's the residual value of a high emission vessel going to be 10 years from now? And nobody knows what that is, but it's almost certainly going to be lower than what we were used to considering. And so the action, the business case for acting right now for ship owners is you can either take a lower initial return on investment, and if you knew what technology was going to be the winner in your particular space, or you can build a traditional vessel with some engineering that allows it to be flexible in the future, or you can seek government support in grants and tax abatements. And the reality is you have to kind of go down this path. Or 4, you can just invest as always and worry about the future when it arrives. And 4 is not a viable solution. So the business case right now is to jump on the learning curve of one of those first 3 options. The other thing I will respond to, and then I'll turn the mic back over to you, but Paul mentioned the issue of carbon credits. And personally, I think carbon taxes are where we're going to get the motivation in that space, as the stick to the carrots that have to be there too, because cap and trade systems, the government has to make too many decisions to be efficient. And especially in our neck of the woods, the government's not shown itself to be incredibly efficient at change. But they have to answer a question like, how many credits should be issued? Who gets the credits? And typically that's people who already pollute the most. What happening like in Europe when there's not enough credits to support genuine energy needs, or how do you accurately measure different types of emissions in a way that it can't be cheated? Whereas in contrast, tax is it let the market determine how to minimize the tax or maximize the tax depending on what actually changes things. And the problem with governments is the word tax is a real negative thing that the public doesn't like to hear, but either way, the end consumer is going to pay for whatever happens there. So we need to figure out a way to get through perceptions as much as actually the real doing of things, but it requires collaboration on a scale that is completely unprecedented in this industry, where everything has been a stepwise sequential transaction from one player in the value chain to the next step in the value chain.
Thank you, David. And I would definitely like us to come back to some of the commercial mechanisms that we might be seeing this, whether that's sort of market-based measures from a regulatory perspective, or indeed commercial mechanisms within the value chain. But before we go there, I'd like to turn to Jake. John has assured us that the IT is known, at least for today's IT. David also then talked about the learning curve and where that, the importance of us jumping on that early in order to advance. From an ARPA-E perspective, what do you think are the next ITs? What's the next wave and the next generation of technological development which we're going to need for this?
Thanks, Simon, and thanks to DNV and Capital Link for this opportunity to speak. John, had a really good point about fuels, right? The 4 A's: abundance, availability, affordability, assignment. And I think the it, right, the it is here, right? We through Wartsila and through many other tech developers, we have the ability soon to use these fuels, but what we don't have is the supply of those fuels. So the next major challenge and step that we at ARPA-E are really concerned about is how do we provide these fuels, right? In general, broadly, but also in the places they're needed, right, for our maritime uses. And so, one technology that we're really excited about is how can we produce these next gen fuels? How can we produce carbon-based fuels or ammonia, methanol, hydrogen at the scale that we're going to need? And of course, scaling electrolyzers is something that's extremely important. Hydrogen is the base of most of these next gen fuels. So getting green hydrogen is extremely important. We're also extremely excited about reactive carbon capture, which is the ability to take carbon directly from either a point source of carbon, right, such as a smokestack, or directly from the air and turn it back into a useful fuel with electricity. And that's a technology which is at the very early stages, but it has the potential to be massively scalable, deployable wherever you need a fuel, and running on nothing more than air and electricity. Currently, it's quite expensive to do this, but in the future, we're trying to get that cost down to be able to provide these fuels at scale for the maritime industry, as well as other industries. The other major challenge is we have to think about how can we in the US, right? At ARPA-E, we are a US funding agency. We fund US technologies. And we think that ports are one of the major kind of strengths of the US maritime ecosystem, right? We have a lot of ports, we have our inland shipping, we have our coastal shipping, and the world comes through our ports. How can we break into the chicken and egg problem of supply and demand for fuels, right? For these future alternative fuels, for methanol, for ammonia, how can we ensure that when the ships are ready to buy those fuels, the ports are ready to supply those fuels, right? And we think that getting in early with use cases that are high value and not necessarily tied to large ships directly could be a way to do that and to ensure that that supply chain starts getting built up now. So we're looking at, like I said, high value first use cases for alternative fuels such as methanol, ammonia, hydrogen, or even batteries, electricity. One example we're seeing in the Northwest is at the port of Tacoma. One of our performers, Oko Chem, is developing formic acid fuel cells for mobile shore power systems. So they're not providing formic acid as fuel for ships, but they're using it to power these kind of barge-based fuel cell shore power systems. And this allows them to start building up the supply chain for a future fuel, for in this case, formic acid, before the lower price demand that will be expected for ships. And then finally, I'll just hit on one other topic is logistics optimization, right? Someone mentioned optimization on board vessels, and I think that's extremely important, as well as other efficiency technologies. But how can we optimize the entire supply chain system, right? Not just speaking of boats, but also how cargo moves through ports, like from boats through ports onto those other intermodal systems. How will the future of fuels affect these logistics systems, right? How are we going to be able to supply these fuels? Is it going to be a distributed system? Is it going to be centralized? And finally, will shipping look different in the future than the system now? We're seeing a convergence of autonomy, of connected vehicles, right? Internet of Things. Will we see a kind of disaggregation of these large, vessels into smaller, maybe fleet-based vessels that are more flexible, fast, and deployable, that can compete maybe possibly with on-road trucking or trains. So that's looking very far in the future, but that's something else that we're really excited about.
Maybe while we've got our eyes far out in the future, I'd like to sort of follow up on that concept of the future ship. Because I guess for the better part of 2 centuries now, the means by which we propel ships mostly has been, we take an energy storage mechanism, we burn it, we convert that into rotating energy, and we make a propeller go round. Are we doing that wrong? Should we be broadening our thoughts there? Should we be looking at, we had an audience question actually asking hydromagnetic propulsion, for example. Is there something out there that we should be putting more focus on that will give us some big wins here?
I do appreciate the question about magnetohydrodynamic propulsion, because that is a topic I just learned about since starting here at ARPA-E, but it's one of the most kind of sci-fi things I've ever heard of. It is a very interesting concept, and it's it's been demonstrated. And to answer the question directly, there have been updates in the past few years. We have seen a couple of proposals actually come by our office, mainly based on the kind of advances in high temperature superconductors. The question remains on whether it's actually a more energy efficient way to propulse a ship, right? It's not necessarily, it's different. It's burning a fuel and turning a propeller, but on the overall, right, as we mentioned before, well to wake, how does the actual energy look? It's also powered by electricity, right? And at ARPA-E, we think about electricity a lot. For heavy shipping, we still see liquid fuels as the primary method going into the future, right? The energy density, based on current and any battery technology we can see in the future, the energy density just cannot be beat by batteries or electric energy storage compared to liquid fuels, which is why we're still focusing on producing these carbon-based and hydrogen-based fuels. So I think that's, we're going to continue to see these liquid-based fuels, and if you could propel a magnetohydrodynamic drive using those fuels, maybe that would be the best of both worlds, but remains to be seen.
Thank you, Jake. I'd like to turn away a little bit from commercial mechanisms now, just from technology rather, and switch back to commercial a little bit. And I'll maybe start with Paul. I mean, we've talked in a number of places now how the value chain is fragmented. We don't have commercial incentives built up in there at the moment. What do you think you would need in terms of a commercial incentive around this to drive decarbonisation and to actually encourage it? You're on mute, Paul.
Would have gotten there originally. Thanks. Thank you, Simon. I think David mentioned it, and I use the word carbon credit, and I think it's actually the value of carbon, whether it appears as a tax or a credit, is part of the solution, and that will allow the connection for a customer in the value chain to decide where he or she is going to put their money, and what operator they're going to choose. And that's sort of one of the key linchpins. The other pieces will fall into place based upon that, which is, how do you establish the commercial terms? How do you exchange the value of what that carbon is? How do you make your contracts show the value of sustainability and decarbonization? And I think that's what needs to happen. I think Dr. Russell also pointed out around optimization. And as we look at optimization, we talk a lot about that just in the small vessel space. So ship assist and escort, do we have before we begin to build new vessels and replace a fleet, how do we get our customers to pay for that? So if the box ship is paying X for a service and we can offer a carbon-free service, how does that container ship company receive value from that? Because they want to get the best price. Again, establishing that. When we go into optimization, then what's the right number of tugs to be in a port? So, am I building 18 tugs or am I building 12 tugs to serve a port? So all of those pieces need to fall into place, and that commercial incentive or commercial drivers rest is going to be spread through the value chain, all the way from the port authority to the end purchaser of whatever product is being transported.
Thank you, Paul. And I mean, I think maybe doubling down on that a little bit, John, I mean, what if we look at our main contracting mechanisms today, you know, what would charter parties and contracts of affreightment you think need to look like in the future to be able to put this value on sustainability, and maybe also to incentivize optimization?
Very good question. And I think we're going to see a revolution in the language and context of how charters are conducted. For years, charters language has essentially been, since the days of sailing ships and Christopher Columbus, move my product from A to B safely on time. The good history with me, it's a reverse auction, lowest price wins. There's no KPI or metric related to the environment. And the operational decisions made by the king, the charter, whose wishes are the command of the ship owner, drive the operational emissions dramatically, much more so than even the technology of the ship or vessel has. So it comes down to who's going to pay for it, as Paul said. And there we also have another disjointment. If I'm an end consumer and I'm willing to pay 10 cents more a gallon for gasoline that's delivered on a clean value chain, I'm a single consumer. But the trading desks are not dealing in gallons, they're dealing in millions of tons of cargo, crude or other products being shipped. 10 cents to them on a gallon is enormous amounts of money. So they're going to drive the other way. So you have a disconnect between the end consumer and the chartering desk, where the decisions are made based upon historic criteria that exclude still the environment. And I think we're going to see some watershed changes. Also, you know, ships are just not transporting cargo from A to B. Oftentimes they're incarnated in a very, very detailed logistics puzzle where sometimes that ship is a storage buffer. And sometimes the metrics on emissions don't recognize that. So there's going to be a little give and take, but obviously I think Paul's right. He, man who pays, which is not the chartering desk, it's the end consumer, has to have the voice here.
Thank you, John. David, I'm going to pass you now a question that we're getting from the audience. And just a reminder to all of our audience, if you have questions that you'd like to direct at the panel, you can use the Q&A function, which should be at the bottom of your Zoom window. David, we talked about the challenge around alternative fuel supply, and Jake talked to us about what we might be able to do at the production end. I want to zero in now on John's second A, availability. Who do you expect is going to lead the infrastructure development that we're going to need for alternative fuels in the USA, David? Where do you think the money's coming from?
I think if you're looking in the US, you're going to have a different answer to that depending on what type of vessel and what type of service. At the end of the day, conventional fuel providers will start looking to shift into more sustainable fuels. New fuel providers will pop up in new technologies, and there's many examples already starting to come. But the real question is, you first have to answer, what fuel do you need in what location, at what time, and what capacity? And one of the things that I think is really going to start that conversation, it's going to be an industry conversation between different sectors. I was on a call with talking to some of our Canadian members, where they were said there's enough biodiesel to handle all the maritime activities in Canada today, but the problem is that's also just the amount you'd use all of it up, and that's the exact amount that the aviation industry would use. And aviation is way more inefficient environmentally. So, you know, and this builds back into Paul's concept of, at the end of the day, end consumers are going to pay for things. But you know, if you're ordering something from Amazon and it's traveling from China to the US, are you going to have the option to say, okay, the price isn't different, but instead of 2-day delivery, if you can take 7-day delivery, we can move it on water and have a totally different environmental footprint. So it's not just about price. It's about, And if you start seeing a shift away from conventional fuels, there's a tremendous amount of the shipping in the US that's moving around conventional fuels, oil and gas products, gasoline, those types of things. It's not that all of that completely goes away in the future, even in a decarbonized future with lubricants and different things, but it's going to change the nature of shipping. And if I could back up a little bit to tie in Jake's last comments and Paul's and John's a little bit on this topic, but a little bit broader, our higher level view. To start any change activity, you have to start with a vision of what the future looks like, and you have to believe that it's possible. And the timing of doing this very quickly, especially in a place like the US, where to do it as quickly as 2050, you've got to take care of existing assets that are going to live much longer than 2050. You have to take that perspective of not just improving to 2030 from where you are today, and then improving a little more to 2040 and improving a little more. You have to do that because the area under the curve matters. But you have to look at that vision and say, what can it look like? And then back up. So then what has to be done by 2040? And then back up. So what has to be done by 2030? And then say, what should we be doing today? And think about those two factors in your roadmap and make sure they can both happen, collectively and not get in the way of each other. So, Jake mentioned optimization. There's technologies we can use right now that we think can take out 30 to 40% of the emissions just by looking at the industry as a whole as an optimization problem. So we track, vessels and where they are, but we can use machine learning to track what that's likely to look like a week from now. And you can start tracking how much are these vessels full or have capacity to move things. So your problem, the whole way contracting works, is not going to be one charterer talking to one ship owner. It's going to, and then reverse auctioning a day rate. You're going to be looking at their space on that vessel that can move what I need to move, when I need to move it, to where I need it to go. And again, it's that Uber kind of mentality, but you can start building that capacity right now. There's no new technology, no fuel, and you can instantly take out a lot of emissions. But if you start thinking through all those different caveats, the future looks like there's a lot of autonomous vessels. There are global optimization models that are constantly being improved at exponential levels. The fuels will have to be part of that. There will be new fuels and infrastructures. I think Paul mentioned early on, we're 15 years away from really figuring out at scale how much we need to do. But one of our member companies is a startup that's looking at producing green methanol in the Midwest, because two things are happening at scale in the Midwest. A lot of corn turned into ethanol, and a lot of windmills going up that you can get very cheap electricity to electrolyze hydrogen. And you can do a green, if you will, SMR process to create fuels. And those fuels can drop into today's infrastructures. They're not cryogenic. They're not the toxicity of the ammonias and things, which we have to be working on at pace now too. But there is no one sector that's going to come back to your question full circle here. There's no one sector that's going to do this. Everything has to, and ammonia is a great example. We know how to make ammonia engines. We know how to make ammonia. Pricing that, okay, what are you going to do to fertilizer, when you start taking up all the ammonia for shipping? But a small engine fire and you've killed your entire crew.
No, absolutely. I think some of the challenges that we will see around these fuels
it's a holistic thing. And so if you look at the shipping value chain as just a logistics value chain, the interfaces are not getting just the internal players to work together. It's interfacing with other sectors, because you're going to be sharing fuels with aviation, with road transport, with city power grids. And right now you've got multiple government entities that don't talk very well to each other on how to deal with that and regulations on that. And all of that stuff has to come together. So it's a very complex question, and probably provided an equally complex answer or food for thought.
No, absolutely. We are very rapidly approaching the end of our panel session here today. I see Jake is already addressing some of the questions in the Q&A that we've not been able to get to. I would close by saying thank you to all of our panelists today. I think this has been an engaging discussion and I hope informative and useful for our audience. And thank you so much to Nicholas and all of the team at Capital Link.
Well, I would like to say from my end, thank you very, very much for a great panel. This is one of the topics that is really, I think, on top of everybody's agenda for the industry globally and certainly here. So thank you very, very much to all of you for a great panel discussion.
Thanks very much, Simon.
Thank you.
Yes.